Okay, hello friends and welcome. My name's Shawn Willsey, geology professor, and today is Friday, November 10th, 2023. I thought I'd put together another update on the things that have been going on in Iceland. There's been some development since my last update earlier in the week, so I thought I'd get you up to speed on some of the data that we're looking at. There's been some interesting developments and things that have changed a little bit. So let's just get right into it. And then at the end, we'll talk a little bit about some of the effects and how it's working and affecting the community and some of the things that they're struggling with over there in that part of the world. Again, near and dear place to my heart, an area I really love and have explored on about 4 or 5 trips. So let's go right into the data here. So remember the area, the Reykjanes Peninsula, which is the southwest peninsula of Iceland, is the place we're focusing on. And we've had earthquake swarms in this region since late October, mainly in this region here, north of this small town of Grindavik, and adjacent to the Blue Lagoon, which is a big tourist destination, and the power plant. There's a large geothermal power plant here as well. And so this is the area of concern. But in the last, I'd say 48 hours or so, there's been a significant change in what the earthquakes have been doing. So let's look at those earthquakes right now and just kind of see what they've been doing. This is the Icelandic Met Office, which is the best thing we have for the most part for that records the earthquakes. You can see these are earthquakes in the last 48 hours, so last 2 days. The green stars would be earthquakes above magnitude 3. So this shows you on a map their location. The colors correspond to the time of the earthquakes since this image was made today at 4:25 local time. And so red would be really recent, and then you can see as you go orange, yellows, blues, the earthquakes get older. So definitely a huge clustering and an intense swarm of earthquakes happening in this region. The chart is also interesting as well. It shows you the magnitude of the quakes going from Wednesday evening through Thursday and into the early part of Friday. And so you can see this big spike here late Wednesday night. Some of these earthquakes were several above magnitude 4, a couple approaching magnitude 5. This is what had a lot of residents in Grindavik and other areas in that region just really rattled. People reported that they just couldn't get to sleep. And I can imagine that with every earthquake, you're wondering if that's the earthquake that opened the volcanic vent. Like after every earthquake, my mind would be racing towards, okay, is there actually lava flowing downhill towards my home and my community? And so I think a lot of people got out of town and went somewhere else. But for those that have stayed, I'm sure it's just been a really unnerving set of days. So our thoughts are with you. And then you can see the earthquake still felt though. Usually an earthquake that's above magnitude 3, if it's close to you and it's shallow as all these earthquakes are, then it's likely to be felt. So you might wonder like, well, what are all these earthquakes being felt by residents? And the answer to that's no. The vast majority of them are small and they're not felt by people. But anything above, I'd say, magnitude 3 or so, and there's lots of variables here, like what you're doing, your home construction, the rock type. But generally, for at least people in Grindavik and other communities near this area, anything probably above a 3 would be felt. And so you can see them kind of tapering off. Thursday was a little bit quieter. Thankfully, and then things have ticked up a little bit here as we work our way into Friday. And there's another website that I was turned on to, and this is run by an individual, so you can buy him a coffee down here and support his work, which is great. So he's getting all the earthquakes straight from the seismometers. This is a little overwhelming here. Let me kind of maybe make this a little cleaner, but there's Grindavik down here, the bottom of the map. Every one of these little circles represents an earthquake, but right now I've got it set for anything above magnitude 0. You can also change the time range. So if we just look at earthquakes in the last, let's say 6 hours, that cleans it up a little bit. Well, maybe not that much. Let's go back. Let's just say last 2 hours. Yeah, that cleans it up a little bit. Let's maybe get it even further. But I think the point here we're seeing is that there's been a lot of earthquakes. This is just the last 30 minutes. And so you can see each earthquake you can click on and see its magnitude and depth and information. So a 3.8. So there's a lot of ones, twos, and threes, even a 4 hidden in there, it looks like, a 4.1 within that time. But the big thing to notice here, if you paid close attention Well, that one's probably not going to show it well, but what the area we were focusing on the last time I did an update, here's the Blue Lagoon and the power plant here. Notice the earthquake activity that we had seen in this area has moved east of this road, Road 43, and is now highly concentrated in this area here. So it's actually shifted. And so the interpretation, although this hasn't been verified yet as far as I know, but the interpretation would be that the magma has migrated to the east into this region. This obviously spells this is obviously a good situation for the power plant in the Blue Lagoon, a better situation instead of the volcano potentially erupting literally right under their feet. Yeah, so if we go back, again, 18 hours ago or so, we had a few earthquakes over here, but not as many. But you can actually see them moving off in this direction. And now, over the last hour or so, we're seeing a lot of earthquakes here. And I'm also sort of seeing a trend here, sort of a strongly sort of north-northeast, south-southwest trend of earthquakes through this region. We'll come back to that in a second because there is already a volcanic system, a row of craters in this region that could really end up being the place where this magma reoccupies and maybe ultimately erupts there. So pretty incredible. So the big takeaway again is that the magma, or excuse me, that the earthquakes have changed location. We don't know exactly what the magma is doing other than it's intruding into the region. But if we take all these new earthquakes over the last 2 days as indicators of magma movement in the crust, that would seem to indicate that the magma has moved. As that sill spread out laterally, what's happened is it's probably was kind of penned in by the structures and rocks and mountains around it, but now it's found an easier path of migration to the east, and so it's following that, and potentially this is just new magma that's being injected breaking to the east, or maybe the magma body has moved to the east completely. So it probably means one of those two things: is you're continuing to have a steady input of magma, so you're breaking new rocks and creating more space to the east, and that's what the earthquake data shows. Or potentially the magma itself has moved in this direction. So we can talk here in a second about what that actually means moving forward and how that might all play out. Okay, so yeah, pretty concentrated over there. Let's look at the GPS data and see what it can show us. So I've got that here on a PowerPoint. So these red dots here on the map are locations where they have GPS sensors. And so remember, GPS data is going to give us ground deformation data. So it's going to show us which way the Earth is moving in 3 dimensions. So moving up and down, moving east to west, and then moving north to south. And so what we're going to do is focus on this little area down here, which seems to be the area of interest, and look at a few of these stations. So let's start with 2 stations I've highlighted here in yellow. One off to the west, the Elor, this is a row of old craters here, and then the main station that a lot of people have been tracking on Thorbjorn, the big mountain just north of Grindavik. And so, again, the first graph, we have a series of 3 graphs on each of these. The first one is north, and so basically if things move above the 0 value, then the station is moving to the north. In this case, we can see with Eldvorp that the movement was mainly to the south. And again, at the bottom here we have, these are months, so this is August, September, October, and then the beginning of November here. So we really want to just look at the last maybe 2 weeks, 10 days or so of the points here on that. So we got the little error bars there, and then the red dots pretty much right in the middle, the mean or the median, I suppose. And so we can see at Eldvorp and Thorbjorn, there's been a movement to the south. So they've shifted a little bit to the south, which potentially means that the magma is intruding slightly to the north of there and pushing that station southward. And then if we look at the east plot, again, a deflection downward would mean movement. It's a negative east value, so that would be movement to the west. And if it trends upwards, that's a movement to the east. And so what you see nicely here is at the Eldvorp location here to the west, that it actually has shifted further west. and that the Thorbjorn station here in the mountain on the mountain has shifted to the east. So that indicates that the magma intrusion, that the two stations are moving apart from each other in an east-west direction, and that's what you would expect in a simplistic way if you're just thinking about magma intruding in some location between those 2 points. And then because the magma is intruding, we would expect nearly all the stations in the region to show uplift, and that's sure enough what we see on this last plot here, where we see starting around the end of October, around the 26th or so, a marked increase upward in the elevation of the GPS station. So it's moving up. In some cases, it's moved up at or at Thorbjorn, it's moved up almost 10 centimeters, 100 millimeters. So pretty remarkable. That's about 5 inches, which doesn't sound like a lot, but when you sort of extrapolate that out and look at the bigger picture, it's a much bigger deal. If we take, so that kind of helps us a little bit looking at two stations that lie presumably on either side of where the magma is or was potentially. If we look at two other stations shown in yellow here that are north-south of each other, these ones are interesting because they show opposing trends as well. The Svartsengi station here in the north shows movement to the north, so that would imply that the intrusion is south of it. So this is just north of the power plant. At the same time, the station near Grindavik shows movement to the south, and so it's moving again away from this intrusion as well. Pretty marked movement to the north here. If we look at the east-west plots, again, they're opposite. The northern station here is moving to the west a little bit, and the southern station is moving a little bit to the east. And then both stations are showing that really pronounced uplift there, and sometimes again in around 10 centimeters or so of uplift. So hopefully that was helpful to you, just looking at some of the GPS data. So what have all these earthquakes done? Obviously, earthquakes of this magnitude not only are felt, but they can sometimes cause a little bit of damage as well. So this is the main highway from Grindavik up towards Reykjavik and some of the other towns, and the airport here, highway or road 43, and you can see some of the minor cracking here. Now the road's in good shape, it's still drivable, but there's been cracks that have opened up. These are just responding to the shaking of the ground. They're behaving brittly, and so you're getting some of these cracks in the ground. So these probably warrant some monitoring, and in some cases, like in Hawaii in 2018, the cracks on the roadway were a big indicator. Actually, later in as that eruption really started getting going, we actually saw some of these cracks open up and gases coming out of them, and eventually these became the sites of a volcanic eruption. I don't know exactly where along this road this photo was taken, but probably somewhere along this stretch, I would guess, between the power plant and the fishing village here. So, okay, so let's go back to talking a little bit about some other things that have gone on in the last few days. So the Blue Lagoon has been in the news quite a bit, and for good reason. It's again the biggest tourist attraction in Iceland, and there was some controversy about whether it should have been open, and some folks thought that they were behaving irresponsibly by letting tourists still come there. I think on my last update they were still open, but they were suspending all their online bookings. And now they've actually completely shut down, at least for a week or so. So it looks like they'll reassess the situation on November 16th and see kind of where they're at. And, it kind of makes sense. I can imagine being at the Blue Lagoon where you're supposed to be soaking in the hot water, maybe getting a mud bath or a massage or something. You're supposed to be relaxing and feeling some of these earthquakes, especially the ones that were felt on Wednesday. That would be pretty unnerving, not knowing if, again, each earthquake represented the actual eruption beginning at that time. So the Blue Lagoon shut down, but there's no significant damage to the Blue Lagoon as far as I know, nor to the power plant, which is still functioning. But they're definitely making some precautions in the area. And so let me go back to this view here. And so again, we thought that the eruption was going to happen somewhere in here on some of my previous updates, just based on where the earthquake swarms were taking place and some of the GPS data. Um, there's an old row of craters over here. Take that off and you can see these craters called the Elor Craters. Um, and I'm not sure exactly when these erupted within the last few hundred years, probably those 1200, 1250 AD eruptive events in here, probably in that time frame. And so there's this row of craters here, and there was some concern that maybe this magma would move over and start erupting in this area. But the big thing that's happening now is because the magma has shifted, so let's take those off. We don't, based on what we're seeing now with the new seismic activity in this area, now you can see a real distinct row of craters. It comes up through here, kind of is offset a little bit, runs up through this area, and then you can see this nice little linear trend of volcanic vents and craters here. This is called the Sundhnúkur, Sundhnúkur. I probably butchered that, so I apologize. Sundhnúkur line of craters. And so now this may be the most likely, at least today, as the way things are standing, location for this next eruption. This is probably, I don't know if it's better. It's better for the power plant in the Blue Lagoon because it would be probably a little bit harder to get the magma over there, although we need to look at the topography really closely. This is, let's see, 380 feet. It does slope downward towards the power plant, but I think it's probably a steeper slope down towards the village. So now we're looking at possibly the eastern half of Grindavik, as well as the harbor potentially, and this highway, this road being the area that would be potentially impacted. Again, we don't know for sure what's going to happen. There's a good chance that magma intrudes, the earthquakes die out, the magma stays there and starts very slowly cooling and crystallizing and doesn't erupt for a while, or maybe never erupts potentially. But if the trend keeps continuing, I mean, especially with some of these larger earthquakes we're seeing in the migration, it might mean that it is going to erupt again. What we're hoping for is if it's going to move east, we'd love it to keep moving east. Like if it can just move a few more kilometers to the east, that would keep the power plant, the Blue Lagoon, and Grindavik all out of the crosshairs, and then we would end up with an eruption back here where we had the last three eruptions, which were in these valleys, accessible to tourists and a great destination to hike to and check out a beautiful eruption, but not really threatening any, if much, infrastructure. And so time will tell. This is a new trend just the last 2 days in terms of what's gone on there. So again, we don't know for sure. In the meantime, what have people in Iceland been doing? And just, in reading some articles and listening to some folks who are there, there's a couple different things that have been happening. So one, I teach a natural disasters class here at the college, and this is a good example of how to mitigate a hazard. And you can do this in a couple different ways. So for example, a volcano is really different than a hurricane. A hurricane, we can see it on satellite imagery. We can assess its strength. We can model and with relative certainty almost project its position and where it's going to go over the next couple days. So we could see a hurricane forming off the coast of Florida, know that in 2 or 3 days time it's going to impact this section of shoreline, and make some pretty good estimations as to what the impact is going to be. So we know where it is, we know when it's going to get there, we know roughly how big it's going to be. And that's amazing that we were able to do that. With volcanoes, we don't have any of that for the most part. So we don't know, we know where it is roughly, but we just talked about the fact that this thing's actually moved potentially. The magma might have moved to the east. So we don't know exactly where it's going to erupt, and we can see that the exact location of this eruption is going to play a big role in how damaging it is to residents and infrastructure there. We don't know how big the eruption is going to be. We've got some estimates of how much magma has been intruding into the crust, but we don't know how much of that's going to erupt, at what rate it's going to erupt. There's still a lot of variables there. So we don't know the where, we don't know the how big, And so it's a trickier eruption. So there's really two ways to plan for these things. You can either um, one one way to do this in the terms of mitigation is you just wait and you react. So you basically say, well, we'll wait till it erupts, and when it starts erupting, we will pour our resources into figuring it out and doing the best we can, getting people out of harm's way, protecting infrastructure. So that's what we would call a reactive mitigation strategy. Basically, hey, we're going to wait till it happens and then we'll react to it as best we can. And that's one way to approach this. Another way is to be more anticipatory. So basically, you're saying, hey, we know this thing has a really high chance of erupting. Um, we know there's a power plant there. We know there's a town nearby. Let's start doing stuff now. And we know what kind of eruption we're going to get. It's going to produce mainly lava. We can get people out of harm's way, but let's start working now to maybe divert the flow, protect some of the homes and businesses, protect the harbor potentially. We could start by digging trenches. So that would be more of an anticipatory approach. Basically, you're saying, hey, I know this thing's very likely to happen, and I'm going to do something now on the front end to reduce or mitigate the impacts of the event. Maybe trying to transition some of the area off of the power supply. I know they've got some diesel generators in Grindavik, and I'm sure other communities in the region are doing something similar. How are we going to get water? That sort of thing. So it's a really interesting case study, depending on how this plays out, into that sort of approach. So time will tell, though. I will be sure to put together another update should anything develop and happen here. But hopefully that was helpful, just looking at some of the new data, the earthquakes, the movement to the east, which is a good sign, I think, overall, at least for the power plant in the Blue Lagoon. The fishing village is still very much at risk, and so we'll just have to see. And then lastly, we've been talking about the webcams. But the webcam that you actually want to switch to now, so the webcam I've been using was this one, and it's sunset there in Iceland. So there's the Blue Lagoon and the power plant on the far right. Off in the distance is Keflavik and the airport. And so this was the area we thought would start erupting. But if you want to start watching these webcams and seeing if anything happens, because this would be the first place to see it, right? If you happen to be watching the live webcam when the vent opens up and the lava pours out onto the ground, this would be the very first place to see it. But really, the better one now, if we're sort of in agreement that now we think the most likely location for the eruption is over on this side, then we actually need to be looking at now. Luckily, it's another camera, but it's on the same mountain. So we have one camera up here on Thorbjorn pointing to the west or northwest, kind of looking at this area. But there's another one, another camera that's pointed to back to the east towards where we had some of those other eruptions there. And so more or less the rough view that this camera gives us is something like this. And so you'll be able to see when I switch back to the camera, you'll see this little road in the foreground, this little cliff thing here. You'll see the main highway, and then probably won't see it as well because it's getting dark there, but then this row of craters. So if we had that eruption east of the highway, the one I've been talking about, this would be the camera to look at here. And this is the camera you'd want here if you go to your webcams is the one that's positioned on this one here, Fagradalsfjall, which was the volcano that erupted a few years ago. So yeah, it's kind of panning back and forth, but yeah, this is the row of craters out here. So you'd see something pop up in this area over here. So we'll have to see how that plays out. One last thing it brought to mind, if you look at this mountain, Thorbjorn, and this, like a lot of these big kind of steep mountains, especially in this part of Iceland, all these very steep hills are actually ancient volcanoes that erupted underneath ice. So when Iceland was covered with a big ice sheet that extended out to the coast, these are volcanoes we call hyoclastite mountains, or sometimes they're called tuyas, that erupted under under the ice. But anyway, the main thing I wanted to point out here is these cracks here. So these are actually faults. There's actually two discrete faults running more or less north-south, kind of northeast southwest, I guess, which is the dominant trend of structures and volcanoes in this part of Iceland. This is a little bit of a graben, so it's actually, you can see the crack that's formed here. So this is not a volcanic fissure. This is a tectonic fault that's broken open this old subglacial volcano since then. But more or less that trend is similar to some of these trends we see over here. So anyway, hopefully that was helpful. It was fun running through this with you. It's fun to watch this develop. It's obviously also stressful because, again, for the Icelandic people in that area, this is not necessarily a fun time. So I want to be very sensitive to their concerns as well. But as a geologist, this is an exciting time to watch the data come in and speculate and wonder a little bit about how it's going to go. Again, we don't know for sure if it's going to erupt. It's a possibility. I'd say, again, I'd probably keep it around 70%. I know I've said that before. We'll have to see. Definitely within the next few weeks, the proof's in the pudding. So if something were to happen, I would expect it sooner rather than later. I don't think it's going to keep doing this for months and months. I think the next few weeks will really show us what this sequence of magma intrusion and earthquake activity is going to do. So thanks again for joining me. Appreciate your support in helping me put together these updates, and we'll see you next time. Take care.